Great. So hopefully by now you start being a bit more warmed up with how we develop little pipelines. You just did a small example in the first exercise. And so now in the upcoming lessons, we're gonna slowly but surely show you how we can incrementally improve our pipelines by adding very specific things or changing things. And yeah, and every lesson is gonna have a focus. And this lesson's focus is going to be how to make our Snakemake or our workflow more general purpose and also more robust in a way. And so this is the end pipeline that we had from the previous exercise. As I said, it was a very simple one just to get started, where we had two rules, one that echoed hello world into a file, and then another one that took this file and copied it into another file. So very simple thing. However, within this very simple workflow, we can already start changing some things to make it better. And the three things that we're going to focus on this lecture are the three that are listed here. And the way that we're going to tackle them is what's in green on the right. So the first thing we're going to focus is on the usage or avoiding the usage of hard-coded file paths as much as possible. And by that I mean that if you look at the rules in this little workflow, both in the output and in the shell directives, we have paths that are hard-coded. So they are written there as a string. And while this is valid and this works, there are ways to make our workflow more robust to problems that can arise from this. So for example, if I change this path here, but I don't change it here, then this rule will produce an output that is not the same that is in here, and that will trigger an error and stop the workflow and things like that. And so we're going to start focusing on the usage of placeholders and wildcards, and more specifically, we start with the placeholders. And so placeholders are going to be noted in the code that we show in the slides as purple, just so that we keep the color code. And from the Merriam-Webster dictionary, they are defined in these two different ways. One is a person or a thing that occupies the position or place of another person or thing. A bit more of a mathematical definition would be a symbol in a mathematical or logical expression that can be replaced by the name of any element of a set. In the end, what matters is that, as I said, we have paths that are hard-coded, for example, in this case, in the shell directive, and we want to avoid having these strings and having a way that is more robust to changes in the code. And the way we do that is through placeholders that look exactly as I show here. So the way that this works, these are, for example, input and output are placeholders, and they are in the shell directive, and this work in a similar way as the f string in Python, if you're familiar with that, where you write f and then quotes, and within the quotes you can use curly brackets to put things that are going to be evaluated when you actually run that in Python. And similarly in Snakemake, these values that are in the curly brackets, for example, input, will be replaced with the value of the input directive here, for example. So this Snakemake will take it and it will convert it into move data test.txt to results rename test.txt. And in this way, you can see that you can change these things here and you don't have to worry about the shell directive, which makes your workflow more robust. And yeah, these are two types of directives, the input and the output, but there are others, like for example, the log, benchmark, params, and we're going to see them throughout the next exercises. And so if we update our workflow now, we see that it has the placeholders, and that looks already much better. And so another thing that we're going to do is to use wildcards in this case to make our workflow more flexible. And wildcards, you can think of them as variables that will be automatically inferred by Snakemake. So we look at this rule here, we see that once again we have hard-coded paths where we have data test.txt as the input and results renamed underscore test.txt. This is hard-coded. However, we can use wildcards in the way that is noted here, which is going to be in red in the examples. And once again, we use the curly brackets and we put here a wildcard. Now, what is this going to do? Well, what this does is that it allows you to build a flexible path in the different input, output, etc. directives that are going to be built based on what you ask Snakemake to output for you. So the way that this works is that if you remember from the exercises, we interacted with Snakemake by launching this command called Snakemake course, in this case 1, and then we asked for a specific file, which is known as the target file. And then Snakemake takes this path and it looks at the outputs of the different rules. And what it does is do a regular expression matching, where it tries to find which rule produces an output that looks like what you're asking for. In this case, the rule rename file produces a string that is results rename underscore something.txt. And this something is flexible in the way that it can take the value that it needs to take for this string to match this pattern here. In this case, the wildcard file would take the value test, and that would then be propagated to the input, and then the input would be data test.txt. Right. So I hope this is clear. But yeah, one thing that is important is that once we have wildcards, since the values of the wildcards are going to be determined from the target file, then it forces us to ask for an output, because Snakemake otherwise doesn't have a way to guess what the value of that wildcard is going to be. And that implies that the target rules cannot contain wildcards. Yeah. Of course, it's not like you are not restricted to having only one wildcard per rule. You can in fact have multiple, as many as you need, really. And in this case here, we have two different wildcards. Once again, as far as in the target file, we are specifying a string that is going to allow us to have the values of those wildcards, we're fine. So in this case, once again, we compare this string to this pattern, and we see that file would get the value of test, number would take the value of 1. We propagate this to the input, which would mean that the input is data test1.txt. And similarly, not all of the directives need to have the same wildcards. So for example, we can have in this case, the output directive has two wildcards, file and number, but the input has only one. And this is not a problem because the value can be propagated. But there is a big and important thing to keep in mind, and is that, as I said, the values of the wildcards are determined from the output directive. And that means that in any other directive that you have wildcards, those wildcards need to be present within the output, and there has to be a way to determine their value. So that is a very important thing, or you're going to start getting errors related to Snakemake not being able to figure out the values of those wildcards. Good. From the directed acyclic graph perspective, what happens is that when you have wildcards, now you are flexible to your string matching more than one file, or your wildcard having more than one potential value. And that means that you will be spawning as many jobs for that rule as wildcard values they are. So to give you an example, imagine that you have a wildcard for sample, and then you want to run fastqc on each of the fastq files that you have, and the input has the wildcard sample, for example. That will mean that if you run the thing properly, you will have as many jobs for the fastqc rule as values the sample wildcard will have, if that makes sense. Good. So yeah, this was the first part, the hard-coded file paths to increase the robustness and the flexibility of our workflow. Yes, Sebastian.
Quick question: can you use standard regular expressions rather than these file and NB ones?
Well, you can. The way that you denote the wildcards in the directive is going to be with this. You can use whatever name you want, but you can actually constrain the values of those wildcards with regular expression things that in the Python way through, if I remember correctly, the wildcards directive. So there is a way to restrict this. But the way that you're going to define or define them in your workflow is going to be through this notation, the curly brackets, and a name that you give your wildcard that is supposed to be self-explanatory in a way, if that makes sense. Good. Good. So with that in mind, now we're going to jump into another thing that we want to be able to have, and that someone already mentioned in the course, and it's the case when we have multiple inputs or outputs within a rule. And of course, there can be cases where our rule either requires multiple inputs or produces multiple outputs. And of course, Snakemake has a way to deal with that because it would not make sense to not have it. And the way that this is declared in the Snake file is that, for example, in this case, in the input, we have two inputs, and we just have the two paths separated by a comma. And the comma here is very important, otherwise you will start getting problems. The way that this will work is that when you combine this with the input placeholder, this list is going to be then unpacked into a list that is separated by spaces in the shell. So for example, here, when you use the input placeholder, this passes from being two strings separated by a comma to the two strings separated by a space. Similarly to having multiple inputs, we can also have multiple commands, and there are two ways to go about this. The first one, I personally think it's not so good compared to the second one, but just so that you understand it. The first one is when we use single quotes to determine our commands, then we have to separate them by a semicolon. Personally, I think it's just easier to use triple quotes, and then you put whatever you want in there. You don't have to worry about semicolons or anything. So even if it's a one-liner, I just use the triple quotes all the time because it's simpler for myself. But that's personal choice, really. And the part that is also important, of course, is that once we have multiple inputs or outputs, for example, it could be the case that the different commands that we have in the shell directive need to access those independently or separately. And for that, we have two different ways to refer to those. The first one is through, let's say, positional indexing, like if you do in Python with a list. So for example, here we say square brackets input, curly brackets input, and then square brackets 0 to refer to the first element, because this is Python based, so the 0 is the first element, and 1 to refer to the second element. And that is a way you can do it. However, what we personally recommend is the second option, which is using named inputs. So in this case, what you do is that you say, for instance, file 1 is equal to the first file, comma, file 2 is equal to the second file, and then you can refer to these files with the placeholder saying input dot and the name that you are referring. So either file 1 or file 2. And the reason why we recommend this is because it makes everything much more readable by an external person that is not developing this workflow. So if you see that you're taking input dot trimmed reads forward, for example, you know exactly what is it that is going on in this command without having to see what is the first element of the inputs. Right. The exact same thing that I've explained for the inputs applies to the outputs. You can have multiple outputs. They have to be separated by a comma once again. They can be named. They can be accessed through the positional indexing. However, there is one special thing, and is that because of how Snakemake works, once you have multiple outputs, Snakemake expects all of those to be created at the end of the rule, or it will fail. And that's, as Antonin mentioned at the beginning, that's because one of the, let's say, criteria for Snakemake to determine that the job runs successfully is that all of the outputs have been created. So make sure that if you have multiple outputs, that those are created, or you will have problems. Great. And so now we go into the last part, which is a bit more optional, but we still include it because we think it's important. And it's the usage of log files to actually check the behavior of Snakemake once you have run your pipeline. So for that, we use a directive, a new directive that we introduced now that is called the log directive. The way that this works is that you have this log directive, and then you put a value that is going to be a path, and Snakemake is going to take care of creating that file for you. However, there is one tiny little thing that you need to do, and is using this type of notation to redirect those messages to the log files that you have created. And you can redirect it to the log file directly by using the log placeholder once again. So here we have a combination of the things that we've learned. Yes, Tessa.
Yeah, does it also create, like if the logs folder doesn't exist, does it also create that?
Yeah.
Okay,
Yes.
thanks.
Yes.
Thanks.
You're welcome. So yes, we need to make sure that we are redirecting this to this file because Snakemake will not do it for you. Similar to the input directive, and for that matter, all of the directives, you can have wildcards. Well, not all of the directives, but most of the directives, you can have wildcards. But once again, just to reiterate myself, the values or the wildcards that you will use in the log have to be present in the output, because that's the way that the wildcard values are inferred. Just finally, one of the things that we want to recommend as best practice is to have a directory that is used for having all of the logs. And then in there, you follow a structure that makes sense so that you can easily parse the logs. If something went wrong, you can easily go to the file that's going to contain the error messages that allow you to understand what went wrong during your workflow. Right. And so with this in mind, now we're going to start the next exercise. Now we're going to get a bit more serious, let's say, and we're going to start the simple RNA-seq analysis workflow that we mentioned at the beginning. In this session, the focus will be to actually use multiple inputs and outputs to see how we use the placeholders and the wildcards. And also, as an extra, you will get the option to actually create the visualization of your DAG so that you can debug it. Maybe it can help you to see if something is wrong, and also how to use the log files to check the behavior if you have the time for that.